will be doing a dissection of a mammalian heart. So this heart that I have with me right here is it's a cow heart. So we know that it's a cow heart based on the size of it. So it's actually bigger than a sheep or any other mammal that is out there. So this part of the heart, as I'm holding it like this is the front of the heart. So I know that this is the front based on the fact that when I am actually holding it like this, there's a structure right there that is branching off on its own. You see, I can put my finger in there. So this is the pulmonary artery. So usually in a heart, this structure will be responsible for taking deoxygenated blood from the right ventricle to the lungs to be oxygenated. So it will usually just branch off on its own. Right at the back of this atrium, you see there's these structures, these thick-walled structures right there. So this is the aorta. So actually the aorta is actually this one. You see the way I'm putting my finger. So if you're wondering what that one is, so this is another part of the aorta that is branching off. So usually you find it in cows, but if this was a human heart, this structure, the aorta right there, this thick-walled one, will be branching off on its own and then becomes more blood vessels as it goes out to the rest of the body. But one thing to note is that this aorta, you see, the walls are actually pretty thin. So if you look at the section right there, the wall here is actually very thick. Sorry, it's actually very thick. It's thicker than this wall right here. So this wall is actually thin. This is the pulmonary artery, remember. So at the back of the pulmonary artery, that's where you'll see the aorta, and it's usually very thick-walled. Something to note. One another thing to note, here at the front of the heart, you see these leaflet-like structures. So these are actually called the auricles. So they're actually the outer layer of the atriums of the heart. So if you look at the side, you actually see it. So we know that the heart actually is a four-chambered specimen. So that means it has 4 chambers. So what are those chambers? So if I'm holding up the heart like that, you can actually see it's like the ventricles. So this will be the right ventricle, this will be the left ventricle, this will be the right atrium, and this will be the left atrium. So if we were to now section it right there and open it up like that, we can actually now nicely see the left and the right. Remember, this is the left, right, and this is the right. So if we do a section right there and open it up like that, one thing to note is that on this side, see, so there's that big structure that I'm holding up with my hand. That structure right there is actually called the septum. So this is what separates the left side of the heart from the right side of the heart. So another thing to actually note is that these cleaving structures, you see this cleavlet structure where I can put my finger in, those are called the ventricles. So what do you notice about this? So the right ventricle is actually thinner than the left ventricle. So if you look at the walls, you can actually tell that. If we now hold it like this, look at the walls. So the reason why that is because the left ventricle is only it's actually responsible for taking oxygenated blood to the rest of the body. So it needs more power to pump the blood to the rest of the body. So it pumps it to the rest of the body, while as the right ventricle only pumps the blood to one area, which is the lungs. So the left side of the heart actually holds oxygenated blood. That's why it has to pump it to the rest of the body, hence why thick walls. The right side of the heart actually has to hold deoxygenated blood, so it actually has to pump the deoxygenated blood to the rest of only to the lungs. That's why the walls are actually an indication of some of their functions right there. One thing to see, I'm actually seeing a very beautiful structure right in front of me. It's actually that structure right there. Okay, it's actually that structure right there. So if I put the heart together, you can see that this is actually the first structure that I was telling you about, which is the pulmonary artery. So if you can see here, the pulmonary artery is actually connecting to the to the right ventricle, which is very important to note based on the function. So what will happen is that the right ventricle will contract and then pump blood. So remember, it's deoxygenated blood. So that blood will actually move to this blood vessel right there. You see? This one, which is the pulmonary artery. So it will go where to the it will go to the lungs to be oxygenated, whereby it's gonna come back now into the right side of the heart, sorry, to the left side of the heart as oxygenated. But now how it comes back is not through that vessel right there. It's actually gonna come through a different vessel that connects to the left atrium. So that vessel is actually the one that we call the pulmonary artery. But in this case, oh, there we go. So there's that vessel right there that is branching off. So this will be the part of the heart that branches off to the vessel, which is the pulmonary vein. So it'll come through here, the pulmonary vein, as oxygenated blood, and it's going to come through to the left atrium. So to the left atrium, the blood is now oxygenated, whereby it's going to go through to the left ventricle right there, that cleave over there. So as oxygenated blood, it's now going to be pumped again, so that when the when the heart contracts like that, the blood will now leave through the structure, that huge aorta, which is the blood vessel, that artery, which is the aorta. So it's going to leave as oxygenated blood through the aorta. Now it goes to the rest of the body, which is telling now as to why is this aorta very thick and very dense like that. It's because of its function. So the aorta is actually responsible for now taking the oxygenated blood from the heart to the rest of the body, and it supplies it to the rest of the body, and it comes back as deoxygenated blood through the vena cava. So in this particular slide, we cannot see, in this section, we cannot see the vena cava. However, if it were a human heart, we'll be able to see it quite clearly. But thank you so much for your attention.